This video describes the fitting of scleral lenses using your Medmont E300 corneal topographer and Scleral Sag factor. OCT studies at Pacific University, led by Patrick Caroline, have shown us that the peripheral cornea, limbus, and sclera begin to form a straight line or tangent shape. The cornea may be curved. However, at approximately 10 millimeters, the eye begins to form this tangent shape, which runs past the cornea, through the limbus, and onto the sclera in the majority of eye shapes. When measuring the angles at the 15 millimeter chord diameter, the inner circle, and at the 20 millimeter chord diameter, we can see that the eye is fairly symmetrical in angle around the clock at the 15 millimeter chord. There's approximately 1.7 degrees of differential at the 15 millimeter chord. However, at the 20 millimeter chord, the outer ring, the eye has far more asymmetry. There's 6.6 degrees of differential around the clock on the sclera. And that can be seen in these bar graphs, where the 10 to 15 millimeter chord shows a fairly tight distribution of angles around the clock. However, at the 15 to 20 millimeter chord, the eye begins to show a greater degree of asymmetry. If we focus our scleral lens fitting at the 15 millimeter chord, we can presume that the eye is fairly symmetrical around the clock, which leads us to designing lenses by corneal topography. Now, what is the average angle that exists in the sclera? And on 55 normal eyes, a study was performed at Pacific University to measure the average angle, and that worked out to be 38.4 degrees on 55 normal eyes. Compared to 55 keratoconic eyes, the average angle was very similar at 38.25. So the angles of the peripheral cornea, limbus, and sclera from a 10 to 15 millimeter chord are primarily the same between normal and keratoconic patients. If we convert this to a measurement of sagittal depth, what is the depth of the eye from a 10 to 15 millimeter chord in 55 normal eyes? And that was 1997 microns, or approximately 2,000 microns of depth. Compared with the 55 diseased eyes, the depth was very similar because the angle is very similar. 1970 microns, very close to an average of 2,000 microns for both normal and diseased eyes. Where were the eyes different? They were different in the cornea. 55 normal eyes measured, on average, 1,748 microns, whereas the keratoconic patients showed more sagittal depth, 1,960 microns. If our corneal topographer can measure the sagittal depth from a 10 millimeter chord to the peak of the eye, then we have a very powerful tool for predicting the initial scleral lens required, because we know that the average sagittal depth of the eye from a 10 to 15 millimeter chord is approximately 2,000 microns. And the Medmont will be capable of measuring that sagittal depth. Simply go to your Analysis and Details window, set your chord at 10 millimeters diameter, then measure the weighted average height, the second column, and that will provide you with the sagittal depth of eye. Then you take your corneal sagittal depth, 1,906 microns, add it to your scleral sag factor, your average of 2,000 microns of depth from 10 to 15 millimeters, plus your apical clearance, and that gives you the required sagittal depth of lens if your scleral lens lands very close to a 15 millimeter chord, like this lens does. And this is a method that we can use to more accurately predict the initial scleral lens required for your patients. When doing this from the Medmont software, we could put on a theoretical corneal GP on this patient and determine if this is a good candidate for a corneal GP or if a scleral lens is required. If we put the lens on the geometric center and look at the fluid underneath the lens on the graph down below, there's landing at 6 o'clock and at 12 o'clock. However, across the vertical meridian, there's a significant amount of fluid. If we click our cursor on this point, there is 230 microns of fluid on the nasal side. On the temporal side, 257 microns. And that's observable on the graph down below, where the amount of fluid underneath the contact lens across this horizontal meridian is excessive. And this would cause lateral displacement of the lens. Bubbles form above 90 microns, and we have over 200 microns on both nasal and temporal sides. So this lens clearly would struggle to be centered, and the patient would struggle to find comfort. So therefore, let's fit this patient with a scleral lens. We select our map, go to Analysis and Details, set our chord diameter at 10 millimeters to measure 10 millimeters across the eye. We click on the flat button and observe the weighted average height, the sagittal depth of the eye. And across the flat meridian, the vertical meridian, the eye measures 1716 microns. We might click on the steep meridian to determine the highest axis of depth on this eye, and this works out to be 1800 microns across the horizontal or steep meridian of this eye. Generally, it's better to take the higher of the two values because you would prefer to have your scleral lens go on eye with more depth than required rather than less depth or touch. If the lens has touch, then it needs to be removed with a higher sagittal depth of lens placed on eye. So it's always better to put on a lens with more depth or to err on the higher side in sagittal depth. Therefore, we would take this corneal sagittal depth, go back to our formula, take our corneal sag, add it to the average 2000 microns for scleral sag depth, plus your apical clearance, and that gives you the calculation of lens that you require. And again, this calculation is based on a 15 millimeter chord diameter because the studies at Pacific University were performed at 15 millimeters. If your scleral lens lands very near to a 15 millimeter diameter, this formula will be a highly accurate way of determining your initial lenses. However, if your scleral lens does not land at a 15 millimeter chord, then use the corneal sagittal depth from your Medmont topographer, knowing that 1750 microns is the normal depth of cornea. If you have a measurement of 2000 microns, then you know you should go up higher in sagittal depth in your trial lens set.